April 1941. Fort Halstead, Kent. Engineers huddle over drafting boards beneath task lamps, their calculations filling sheets of paper with penciled numbers and angles. Outside, spring rain taps against the windows of the Royal Artillery Research and Development Establishment. On one desk, a typed minute from the Director of Artillery arrives in a manila folder. The message is clear. The 2-pounder gun has failed in France. Something stronger is needed. German Panzer-threes and Panzer-fours now carry thicker armor than British doctrine anticipated. The engineers know what velocity means, what chamber pressure demands, what recoil forces require. They sketch a weapon that exceeds every existing British gun carriage. The mathematics work perfectly. The ballistics promise penetration at 1,000 yards. But no tank in the British inventory can mount it. This gun will be born before Britain builds the vehicle to carry it. From this paradox begins the story of the 17-pounder. Drafting boards fill the workshop at Fort Halstead on the 10th of April, 1941. Task lamps cast pools of yellow light across blueprints marked in red ink. A design engineer lifts a technical note from his inbox and reads the requirement twice. The Director of Artillery has issued new specifications. Defeat 4 inches of armor plate at 1,000 yards. The existing 2-pounder, a 40mm weapon effective in 1939, cannot penetrate the frontal armor now appearing on German tanks. France proved that. The 6-pounder, a 57mm gun already in development, will help, but retooling factories takes months. Intelligence reports describe German Panzer-threes receiving face-hardened plates and Panzer-fours mounting longer-barreled guns. The British response must exceed current threats by a significant margin. The concept emerges quickly. A 76.2mm bore. A barrel length of 55 calibers. Chamber pressure approaching 21 tons per square inch. Muzzle velocity near 3,000 feet per second. The figures promise penetration well beyond 4 inches, but they also predict recoil exceeding 40 inches of travel. No existing British gun carriage can absorb that force. The equilibrators and buffers in current service will fail. A War Office technical note dated late April states the conclusion plainly. Weapon exceeds existing carriage limits, recoil and equilibrators beyond current pattern. The gun is theoretically superior. Practically, it is orphaned. The design committee accepts the concept in May. The weapon receives a designation, Ordnance QF 76.2mm, later simplified to the 17-pounder after the weight of its projectile. Development proceeds on 2 paths. A towed mounting will be designed from scratch, incorporating the heavy recoil system the gun demands. Tank mounting will wait. British cruiser tanks like the Cromwell and Centaur have turret rings too small and internal volumes too tight. The gun exists on paper. The carriage does not. The tank does not. But the requirement remains urgent. The 17-pounder is accepted into service before Britain owns a vehicle that can fire it in motion. Dust rises through field glasses on the 15th of February, 1943. An officer of the 48th Royal Tank Regiment adjusts focus and tracks movement near Hunt's Gap in Tunisia. The shapes are unmistakable. Low hulls, wide tracks, and the angular turrets of Tiger ones. Intelligence briefs had mentioned Tigers in limited numbers, prototypes committed cautiously. The battalion's Churchills carry 75mm guns adequate for infantry support and effective against soft targets. Against a Tiger's frontal armor, they are insufficient. The officer watches the lead Tiger advance at walking pace, turret traversing slowly. Fires. The sound arrives a moment later. A Churchill takes 6 hits at 800 yards. Crewmen bail out as smoke pours from hatches. Post-battle inspection shows the front plate intact, penetrations entering through the sides and rear. Return fire from 75mm guns strikes the Tiger's front without effect. The after-action summary submitted to First Army in late February records the engagement with clinical precision. Churchill struck 6 times at 800 yards. Front plate intact. Return fire ineffective frontally. The conclusion is simple. British tanks in theater cannot engage Tigers or Panthers from the front at combat ranges. The War Office orders immediate deployment of towed 17-pounder batteries. Turret-mounted solutions will follow when they are ready. But crews need the guns now, this month, before the spring offensive. Crates arrive at ports in Tunisia in March. Some shipments include incomplete manuals. Drill sergeants teach loading procedures beside the gun pits, working out the rhythm of the long ammunition, the weight of the breech, the technique of rapid traverse. 17-pounder batteries deploy with anti-tank regiments in April. The first engagements occur at extended range, gunners firing from concealed positions at German armor silhouetted on ridgelines. Penetration is confirmed at over 1,000 yards. The towed gun works. The question now is whether it can be mounted in a tank and brought forward with armored units, rather than waiting in static positions for targets to appear. Trial officers brace behind sandbags at Larkhill Ranges, Wiltshire, on the 3rd of June, 1943. The first full-charge firing shakes the observation shelter. Dust and smoke obscure the target for several seconds. When visibility returns, the spotting team confirms the hit. A 3-inch homogeneous plate at 1,500 yards shows a clean penetration. The firing trials wing records velocity at 2,983 feet per second with standard armor-piercing capped ballistic cap ammunition. Experimental discarding sabot rounds, still in development, reach 3,950 feet per second in controlled tests. The penetration curves exceed requirements. The gun works exactly as designed. The problem is space. Cromwell and Centaur tanks cannot accept the 17-pounder without major redesign. Turret rings are too narrow. Recoil paths are too long. Internal stowage for the ammunition is inadequate. The gun's breech, in standard orientation, extends too far rearward. British tank production focuses on existing models. Delaying output for redesign is unacceptable. The School of Gunnery at Larkhill and liaison officers from Bovington Tank Museum examine alternatives. One option emerges. Adapt the gun to an American M4 Sherman, a tank Britain receives in large numbers through Lend-Lease. The Sherman's turret ring is slightly larger. The hull has more internal volume. A modified mounting might work. A design committee minute dated 3rd of June, 1943, records the decision. Adaptation to American M4 considered practicable subject to breech rotation and stowage alterations. The 17-pounder can fit if the breech is rotated 90 degrees, placing the opening on the left side of the turret instead of the rear. The loader's position will change. Radio equipment will relocate. The gun will work, but the conversion will be tight, manual, and slow. Each Sherman must be modified individually. The British Army now has a gun that functions, a tank that can carry it, and a production bottleneck that limits how many can be fielded before the invasion of France. Time is the remaining constraint. A stripped M4 Sherman hull rests on blocks in a workshop at Bovington Camp, Dorset, on the 15th of July, 1943. The turret sits beside it, removed to expose the interior. Engineers mark measurements in chalk on the turret ring and hull floor. Calipers check clearances around the recoil path. The task is straightforward in concept, complex in execution. Install a 76.2 mm gun in a space designed for a 75 mm weapon. The difference in barrel length is over 4 feet. The breech, in standard configuration, will not fit. Lieutenant Colonel George Brighty and Major W.G.K. Kilbourne supervise the work. Royal Electrical and Mechanical Engineers teams perform the modifications. The breech is rotated 90 degrees to the left, opening toward the loader rather than rearward. This saves 14 inches. The number 19 wireless set moves from the turret bustle to a different position. A counterweight is added to the rear of the turret to balance the longer barrel. The recoil buffer is replaced with a unit capable of handling the gun's forces. Ammunition stowage is reconfigured to hold the 17-pounder's long shells, each round nearly 3 feet in length. The loader will crouch lower and pass rounds at an angle. The interior is cramped, but the gun fits. The prototype fires successfully on the 30th of July. A Ministry of Supply memorandum records the result. Prototype firing satisfactory. 3-inch homogeneous plate penetrated at 1,500 yards. Penetration tests confirm the Sherman can deliver the 17-pounder's full ballistic performance without compromising accuracy. The mounting is approved for production. The vehicle receives a designation, Sherman 1C Firefly or Sherman 5C Firefly, depending on the base model. The name Firefly originates from British crews who note the muzzle flash. Conversion work begins in August at depots across Britain. Each tank requires approximately 2 weeks of labor. The work is done by hand. Fitters remove the original 75mm gun and mantlet. They install the modified 17-pounder mount, carefully aligning the trunnions. Welders add reinforcing brackets to the turret basket. Electricians reroute wiring around the new breech position. Armorers test-fit ammunition racks, adjusting until rounds slide smoothly. Each conversion follows a checklist 47 items long. Quality control inspectors verify every step. A single misalignment can cause recoil damage during firing. The British Army sets a goal of equipping 1 in 4 Shermans with the 17-pounder before D-Day. Reality will fall short of that ratio, but even a limited number will change battlefield dynamics. Steam cranes lift gun barrels at Royal Ordnance facilities in Woolwich and Nottingham in January 1944. Gauges check chamber dimensions and bore finish. Each barrel undergoes proof firing before acceptance. Crates stenciled QF-17PR stack on loading docks awaiting rail transport. The Ministry of Supply sets a production target of 500 barrels per month. Actual output in March reaches 380, constrained by skilled labor availability and machining capacity. Barrel production is a precision process. The 76.2mm bore must be rifled to exact tolerances. Chamber pressures exceed 20 tons per square inch. A flawed barrel can fail catastrophically. Each barrel requires 42 hours of machine time. Lathes turn the rough forgings to dimension. Boring machines cut the chamber. Rifling machines carve the spiral grooves that spin the projectile. Inspection teams measure every critical dimension with micrometers. A single deviation of 0.003 of an inch causes rejection. The rejected barrel returns to the furnace for reforging. Accepted barrels receive proof marks stamped into the breech ring. Serial numbers are engraved. Each barrel's manufacturing data is recorded in ledgers kept at the Ordnance Board. Tungsten shortages limit early production of armor-piercing discarding sabot rounds. Tungsten cores, essential for maximum penetration, compete with demands for anti-aircraft ammunition and other priority systems. Standard armor-piercing capped ballistic cap rounds become the staple. These projectiles lack the extreme velocity of discarding sabot types but remain effective at combat ranges. Each APCBC round weighs 17 pounds. The shell contains no explosive filler. Penetration depends entirely on kinetic energy. At impact, the ballistic cap breaks away first, followed by the penetrating cap, which normalizes the angle before the hardened core punches through armor plate. Monthly Firefly conversions rise into the low hundreds by April. The Director General of Tank Supply coordinates with Canadian production partners who manufacture gun mounts and assist with conversions. Royal Ordnance Factory Nottingham becomes the primary source for 17-pounder barrels destined for tank mounting. Woolwich focuses on towed gun production. Canadian facilities at Montreal produce carriages and recoil systems under license. Ammunition production occurs at multiple sites across Britain, with additional manufacture in Canada and coordination with United States facilities for specialized components. Production Report Number 4/44, issued in April, states the constraint plainly. Shortages in tungsten necessitate alternative cores. Priority to AA and AT types retained. The AA designation refers to anti-aircraft ammunition. The AT designation means anti-tank. Both compete for tungsten stocks. The Ministry of Supply allocates tungsten based on strategic priority. Anti-aircraft defenses protecting cities and factories receive first claim. Anti-tank ammunition receives second priority. The allocation reflects operational reality. German air raids continue to threaten production centers, and defending those centers takes precedence. By late May, the British Army projects 5 Fireflies per armored regiment by D-Day. This is far below the 1 in 4 ratio originally desired but represents the realistic limit given production rates. Approximately 200 Fireflies are ready for embarkation in early June. On paper, the number appears small. In practice, the gun's lethality means each Firefly has disproportionate impact. German intelligence remains unaware of the 17-pounder's integration into Sherman tanks. Captured planning documents from early 1944 mention towed anti-tank guns but do not reference tank-mounted versions. The Firefly will arrive in Normandy as a tactical surprise. A Firefly of the 13th/18th Royal Hussars edges forward along a hedgerow lane near Tilly-sur-Seulles, Normandy, on the 10th of June, 1944. The commander scans open ground through the cupola. At 1,200 yards, a German Panther moves laterally across a field. The gunner acquires the target. The Firefly halts. The shot is deliberate. The report echoes across the hedgerows. Seconds later, the Panther stops. Smoke rises from the engine deck. The crew bails. This is the Firefly's first confirmed kill of the campaign, recorded in war diaries submitted to 30th Corps. British tank doctrine prior to Normandy emphasized close infantry support, with tanks operating within 500 yards of enemy positions. The Firefly changes this. Its effective range allows standoff engagements at twice that distance. Commanders begin pairing standard 75mm Shermans with Fireflies in each troop, using the shorter-range tanks for high-explosive fire support and the Firefly for anti-tank work. The 75mm gun excels at destroying machine gun nests, bunkers, and infantry positions. The 17-pounder specializes in killing armor. Together, they provide balanced firepower. Troop commanders develop new tactics. The Firefly positions itself in overwatch, scanning for armor threats while the 75mm Shermans advance. If German tanks appear, the Fireflies engage first from long range. Standard Shermans suppress infantry with high explosive and provide covering fire. This division of labor maximizes each weapon's strengths. Regiments that adopt these tactics report higher survival rates and more effective combined arms operations. Those that fail to adapt lose tanks in close-range engagements against Panthers and Tigers. German responses adapt slowly. Early Firefly losses occur mostly through ambush or artillery fire rather than tank duels. By the 10th of July, several hundred Fireflies are ashore. Combined field returns from towed 17-pounders, Achilles self-propelled guns, and Fireflies list dozens of German armored vehicle kills credited to 17-pounder weapons. The exact numbers vary by unit and source, but the pattern is consistent. The 17-pounder penetrates German armor at ranges where return fire is ineffective or impossible. 21st Army Group Operational Research publishes an assessment in late June. Observed lethality of 17-pounder tank installations significantly exceeds 75mm armament in frontal engagements. The report includes penetration data from battlefield salvage. Panther turret side armor, nominally 45mm thick, shows through penetrations at ranges exceeding 1,000 yards. Tiger front plates, 102mm thick, show penetrations at closer ranges with armor-piercing discarding sabot ammunition. The data confirms theoretical predictions made at Fort Halstead 3 years earlier. Regiment commanders begin instructing Firefly crews to avoid unnecessary exposure. The long barrel makes the Firefly identifiable at distance. German gunners learn to target it first. Crews adopt camouflage techniques. Parking in shadows, reversing after firing, changing positions frequently. Some crews add foliage to the barrel to break its outline. Others paint the distinctive muzzle break in disruptive patterns. Survival depends on combining firepower with tactical discipline. The Firefly's effectiveness makes it a priority target. Surviving requires combining firepower with tactical discipline. Units that master this balance achieve kill ratios heavily in their favor. Those that do not lose Fireflies faster than replacements arrive. By mid-July, replacement Fireflies begin reaching Normandy from Britain. The flow is slow but steady. Each loss can now be replaced within days rather than weeks. Gunner training for the Firefly requires adaptation. The 17-pounder's ballistics differ from the 75mm gun. Range estimation becomes critical. A 100-yard error in range estimation at 1,000 yards can mean the difference between a penetration and a miss. Gunnery schools in Britain establish specialized courses for Firefly crews. Experienced instructors, many veterans of North Africa and Sicily, teach the techniques required for long-range precision shooting. The training emphasizes first-shot hits. Unlike the 75mm gun, which crews might fire multiple times to bracket a target, the Firefly's long barrel and muzzle flash immediately reveal its position. After the first shot, the Firefly becomes a priority target for return fire. Hitting on the first round increases survival probability. Gunners practice on ranges measuring 1,000 yards and beyond. They learn to read terrain, estimate distance using landmarks, and account for wind drift. The 17-pounder's flat trajectory helps. At combat ranges under 1,500 yards, the trajectory remains nearly horizontal. Gunners can aim directly at the target without complex elevation adjustments. Loaders train for the weapon's unique demands. The 17-pounder round weighs 60 pounds complete. Loading requires strength and technique. The round is nearly 3 feet long. The loader must extract it from the rack at an angle, swing it toward the breech while crouching in the cramped turret, align it with the breech opening on the left side, and ram it home. The process takes practice. Experienced loaders achieve loading in under 6 seconds. Novices require twice that time. Speed matters. In combat, the difference between 5 seconds and 10 seconds can determine whether a second German tank is engaged before it fires. Commanders learn to position Fireflies for maximum advantage. The ideal firing position provides good visibility, solid ground for the tank's suspension, natural camouflage, and covered withdrawal routes. Commanders scout positions before committing the tank. Once in position, the Firefly remains stationary until firing. Movement attracts attention. The goal is to appear as another standard Sherman until the moment comes to shoot. Some units paint the Firefly's barrel in patterns that break up its distinctive silhouette. Others add cut branches or netting to the barrel to reduce its visual signature. Every technique that delays German recognition improves survival. Radio discipline becomes essential. Firefly commanders monitor troop nets for contact reports. When German armor appears, the information passes quickly. Fireflies maneuver to engage while standard Shermans provide covering fire and suppress German infantry. Coordination between tank types defines success. Units that train together, understanding each vehicle's capabilities and limitations, perform better in combat. Units that deploy Fireflies without integrated training suffer higher losses. The weapon alone does not guarantee success. Proper employment requires doctrine, training, and discipline. Ammunition management also requires attention. Each Firefly carries 77 rounds of 17-pounder ammunition. This sounds substantial, but combat expenditure can be rapid. A single engagement might consume 10 to 15 rounds. A day of heavy fighting can exhaust half the load. Resupply occurs at night or during lulls. Ammunition trucks move forward with replacement rounds. Crews restock manually, passing shells from the truck into the tank's racks. The physical labor is demanding. By late July, the system functions smoothly. Ammunition reaches units reliably. The logistical chain from factory to frontline performs as designed. A 17-pounder towed detachment unlimbers on a road bend in the Bayukin sector in early August 1944. The crew sets the trail spades and traverses the barrel to cover a field of fire. 6 men work with practiced efficiency. The gun commander selects the exact firing position. Crewmen dig shallow scrapes for protection. Camouflage netting goes up within minutes. An Achilles M10 self-propelled gun parks 300 yards to the right, its 17-pounder covering an adjacent approach. The position is part of a layered anti-tank belt established by 73rd Anti-Tank Regiment. Infantry commanders had feared German armored breakthroughs in the weeks following D-Day. The solution was depth. Multiple lines of 17-pounder positions, each covering the next with interlocking fields of fire. Forward positions engage at maximum range. If enemy armor penetrates the first line, it enters the kill zone of the second. If it penetrates the second, the third waits. German attacks must either withdraw after taking losses or advance through successive curtains of fire. Neither option is favorable. The doctrine works. German armored attacks in August encounter curtains of 17-pounder fire before closing to effective range. Towed guns dominate defensive arcs. The 17-pounder's weight, at nearly 3 tons, makes it difficult to move quickly but provides stability during firing. The gun can be fired repeatedly without shifting position. Crews train to achieve rates of fire approaching 10 rounds per minute in ideal conditions. In combat, sustained rates settle to 4 or 5 rounds per minute, limited by the physical demands of handling 60-pound ammunition. The Achilles, a British modification of the American M10 tank destroyer mounting a 17-pounder, adds mobility to firepower. The Achilles carries 50 rounds of 17-pounder ammunition compared to the Firefly's 77. Its open-top turret provides better visibility but less protection. Crews accept the trade-off. The Achilles can reposition rapidly between firing points, complicating German targeting. Towed guns remain in place for hours or days. The Achilles moves after several shots. Crews report front plate penetrations of Tigers at 1,100 yards when using specialized ammunition. Canadian 2nd Corps anti-tank batteries record similar results. By the 31st of August, field inventories list over 1,200 17-pounders in service across all types: towed, self-propelled, and tank-mounted. The weapon's distribution across multiple platforms ensures German armor encounters it in varied tactical contexts. A Panther crew may avoid open fields where Fireflies operate, only to encounter towed guns covering alternate routes. Avoidance of one threat exposes the vehicle to another. A Canadian 2nd Corps report dated August 1944 records a significant finding. Front plate penetration of Tiger observed at approximately 1,100 yards with special shot. The special shot refers to armor-piercing discarding sabot ammunition, now reaching frontline units in small but increasing quantities. The sabot design allows a lighter, smaller diameter tungsten core to be fired at extreme velocity. Upon leaving the barrel, the sabot petals discard, and the core continues at speeds exceeding 3,900 feet per second. At 1,000 yards, this velocity permits penetration of armor profiles previously considered immune. German armored units adapt by reducing daytime movement. Attacks shift to dawn and dusk. Ambush tactics replace frontal assaults. But the 17-pounder's range makes ambush difficult. Positions 600 yards apart can mutually support with overlapping fire. British anti-tank doctrine emphasizes mutual support. No position stands alone. If one gun is knocked out, adjacent guns continue firing. The depth of the defensive system absorbs losses without collapsing. The more German armor hides, the more 17-pounders dictate the terms of engagement. Offensive momentum shifts decisively to forces possessing long-range anti-tank capability. By late August, German armored divisions in Normandy report chronic fuel shortages and replacement vehicle deficits. Even when tanks are available, deploying them invites losses from 17-pounder fire. The operational calculus shifts. German armor becomes a wasting asset, expended in defensive actions rather than offensive breakthroughs. Captured staff papers from Panzergruppe West, recovered in September 1944, include a line notation from the 12th SS Panzer Division. The note mentions long-barrel Sherman and recommends flank attacks at close range. German intelligence initially misattributes the Firefly to United States production, unaware that Britain modified existing M4 tanks. Some reports describe it as a Sherman with 76mm gun, confusing it with the United States M401. The confusion delays effective countermeasures. German tactical intelligence operates under incomplete information. Identification guides distributed in July show standard Sherman profiles but omit the Firefly variant. Crews learn to recognize it only through combat experience. Early tactical orders emphasize closing range quickly to negate the Firefly's advantage. This tactic works only when terrain permits concealed approaches. In open ground, it results in losses. Panzer crews report that closing from 1,000 yards to 500 yards under 17-pounder fire requires crossing a zone where the Firefly can fire 3 to 4 aim shots. German doctrine previously assumed most Allied tanks would be ineffective beyond 600 yards, allowing safe approach under suppressive fire. The 17-pounder invalidates that assumption. German field reports from late summer describe engagement ranges shifting markedly in Allied favor. Assessments estimate average Allied firing ranges at 1,200 meters compared to German ranges averaging 700 meters. This reverses the pattern from 1943, when German guns typically outranged Allied weapons. The 17-pounder's distribution across multiple platforms, towed guns, Achilles self-propelled mounts, Firefly tanks, means German units encounter it repeatedly in very tactical contexts. No single counter-tactic addresses all three. Avoiding open ground where Fireflies operate forces movement into narrow lanes where towed guns wait. Flanking positions to avoid towed guns exposes vehicles to Achilles fire from unexpected angles. Ammunition issue rates reflect the weapon's prevalence. British logistics reports record 17-pounder ammunition distribution exceeding hundreds of thousands of rounds per month across European theaters by autumn 1944. Convoys carrying ammunition from depots to forward units move continuously. Each armored regiment receives regular resupply. Firefly crews report ammunition availability is rarely a constraint. They fire when targets appear, confident that expenditure will be replaced. This contrasts sharply with German experience, where ammunition conservation becomes a chronic concern. A German field note captured in September states, "Frontal armor of Panzer-V vulnerable at greater distances than anticipated. Enemy gunners well trained. The Panzer-V, the Panther, was designed specifically to be immune to most Allied guns frontally. Its glassy plate, 80 mm thick at 55 degrees, presented a line-of-sight thickness exceeding 140 mm. Against standard Allied 75 mm guns, this provided reliable protection. The 17-pounder with discarding sabot ammunition negates that immunity at typical combat ranges. Under favorable conditions, perpendicular angle, quality ammunition, experienced gunner penetrations occur at ranges exceeding 1,000 yards. German command directives change in response. Orders emphasize camouflage, night approaches, and smoke screening. Panzer units receive instructions to identify and engage Fireflies first, recognizing them by the longer barrel and modified hull front. But material constraints, fuel shortages, tungsten scarcity for German armor-piercing tungsten core rounds, and crew training gaps prevent effective implementation. New crews arriving as replacements lack the experience of veterans lost in earlier fighting. Training time shortens as the manpower pool depletes. The quality of German tank crews, on average, declines through late 1944. The Heereswaffenamt, the German Army Weapons Office, cannot increase production of APCR, armor-piercing composite rigid, ammunition due to tungsten shortages. German tungsten supplies depend on imports, primarily from Portugal. Allied diplomatic and economic pressure reduces these imports. Existing stocks are allocated to anti-aircraft and anti-tank weapons, but demand exceeds supply. Frontline units report receiving only a handful of tungsten core rounds per vehicle. Most engagements rely on standard armor-piercing shells with reduced penetration capability. British and American industry, by contrast, continues scaling output. New tungsten sources in the Americas supplement imports. Recycling programs recover tungsten from expended ammunition and damaged equipment. Industrial capacity expands rather than contracts. The battlefield becomes an industrial equation. The side that fires more accurate rounds at longer ranges more frequently wins. By early autumn, German armor doctrine is reactive. The 17-pounder has forced engagements onto Allied terms. German tanks avoid open ground, limit movement to covered approaches, and engage only when terrain favors close range. These constraints reduce operational flexibility and cede initiative to Allied forces. Smoke pillars mark the Seine riverbanks between the 14th and 29th of August, 1944. German columns crowd approaches to bridges under continuous artillery observation. 21st Army Group armored brigades establish blocking positions on high ground east and north of the river. Anti-tank regiments deploy 17-pounder belts covering bridge approaches and crossing points. German plans to disengage across the Seine assume Allied tanks cannot effectively interdict at range. This assumption proves incorrect. The pocket forms slowly, then closes rapidly. German 7th Army and 5th Panzer Army elements attempt withdrawal eastward through a narrowing corridor. Allied air forces attack by day. Ground forces block escape routes by night. 17-pounder positions cover the few remaining crossings. German vehicles attempting to ford the river or use intact bridges enter pre-registered kill zones. Gunners fire at known ranges against predictable approach routes. The tactical problem simplifies to ammunition expenditure and barrel maintenance. Armor-piercing discarding sabot ammunition, now distributed more widely, reaches muzzle velocities near 3,950 feet per second. At 1,000 yards, this enables penetration of heavy armor profiles previously considered safe at that distance. Field tallies from late August attribute a majority of German armored vehicle losses in certain corridors to 17-pounder fire from towed guns, self-propelled mounts, and Firefly tanks. The Saint-Louvier's pocket becomes a killing ground. German units attempting to cross under fire suffer losses exceeding 50% in some formations. Vehicles abandoned on approach roads are counted post-battle. Panthers, Tigers, Stoogie assault guns, half-tracks, and trucks. Many show 17-pounder penetrations. Others were abandoned intact when crews recognized the futility of advancing. An operational research summary from late August concludes, long-range interdiction by 17-pounder installations decisive in preventing organized armored withdrawal. The assessment notes that German armor, when forced to concentrate at few crossing points, becomes vulnerable to massed anti-tank fire. The 17-pounder's range allows guns to engage from positions outside German artillery suppression range. Counter-battery fire cannot silence the guns because they sit beyond the effective range of most German field pieces. The pocket closes faster than German staff planners anticipated. Armored cohesion degrades. Units become intermingled. Command and control breaks down. Vehicles are abandoned to avoid kill zones. Those that attempt passage take fire from multiple directions. Some crews surrender rather than risk crossing under observation. Others destroy their vehicles and attempt to escape on foot. Post-battle surveys count hundreds of destroyed or abandoned German armored vehicles in the pocket area. Not all losses are attributable to 17-pounders, but the weapon's contribution is significant and documented. German after-action reports, recovered post-war, describe a loss of initiative in armored operations. Offensive thrusts will not regain momentum in Western Europe. The 17-pounder's lethality at extended range has strategic consequences beyond individual engagements. It forces operational choices. Withdraw under fire or remain stationary and risk encirclement. Neither option is favorable. The weapon, conceived as a solution to tactical problems in 1941, now influences operational outcomes in 1944. The perimeter at Oosterbeek, Netherlands, tightens on the 17th of September, 1944. 1st Airborne Division holds ground near Arnhem against German counterattacks. 1st Air Landing anti-tank battery positions 17-pounder guns in orchards and near houses. The guns arrived by glider, 24 in total, towed behind horse transports. Each glider landing was a calculated risk. Some guns damaged on touchdown. Others landed intact and were quickly deployed. Airborne planners feared the division would lack adequate anti-armor capability. The 17-pounders provide it. The guns weigh nearly 3 tons each. Moving them without proper tow vehicles requires improvisation. Crews manhandle guns into position using ropes and sheer effort. Once sighted, the guns become fixed defenses. Ammunition arrives by parachute drop or glider. Each position receives a limited allocation. Crews must make every shot count. There will be no resupply convoy, no depot to draw from. What lands with the division is all that exists. German Kampfgruppen, combined arms battle groups, include Stoogie assault guns, Panthers, and in some instances Tigers. Approach routes into the perimeter are narrow, bordered by ditches and buildings. Anti-tank guns exploit this terrain. The 17-pounder's long barrel restricts traverse in confined spaces, but the limited approach routes funnel German armor into predictable killing zones. Several German vehicles are knocked out at ranges under 600 yards, penetrated through frontal armor by 17-pounder fire. 1st Airborne Division war diaries record, without 17-pounders, several penetrations would have been decisive. The statement reflects tactical reality. The perimeter survives longer because anti-tank guns deny German armor freedom of movement. Each successful engagement delays German progress. Each knocked out Panther or Stoogie forces following vehicles to detour or halt. The 17-pounder crews understand their role. They are buying time for relief forces advancing from the south. Losses among the anti-tank batteries are heavy. German artillery targets known gun positions. Infantry infiltration threatens crews operating in isolated pockets. By the 25th of September, fewer than half the original guns remain operational. Some are destroyed by direct hits. Others are disabled by near misses that damage trails or sights. Crews fight until overrun or out of ammunition. Several guns fire until the last round is expended. Then crews destroy the breech blocks and withdraw on foot. 30th Corps relief columns advancing from the south include Fireflies, which engage German armor at long range from road embankments. The narrow corridor of advance limits maneuver but provides clear sight lines. Firefly gunners engage targets at ranges exceeding 1,000 yards. The operation ultimately fails to achieve its objectives, but the 17-pounder shapes the casualty exchange ratio and the perimeter's survival time. Even in a failed operation, the weapon demonstrates its value. Post-battle analysis notes that German tactics now account for 17-pounder presence. Crews are instructed to identify and prioritize Firefly tanks. Intelligence briefs circulate showing the longer barrel and different hull front. The gun's reputation influences both sides' decision-making. German units avoid open approaches where 17-pounders may be sighted. British units increasingly rely on the weapon as their primary anti-armor system. The psychological impact matches the material effect. The presence of 17-pounders constrains German tactical options even when the guns are not firing. Ruhr machine halls stand damaged in December 1944. Roof trusses sag. Assembly lines halt intermittently due to power cuts. German ammunition production suffers under sustained Allied strategic bombing. Factories operate at reduced capacity. Skilled workers have been conscripted into military service. Replacement labor lacks experience. Ordnance High Command struggles to maintain output of tungsten core armor-piercing ammunition. The constraints are material, logistical, and manpower-related. All converge to limit production. Monthly production of Panzer-40, the German designation for tungsten core rounds, declines below 1,000 tons equivalent in late 1944 and early 1945. The figure represents all tungsten ammunition across all calibers: 88 mm for Tigers, 75 mm for Panthers, and smaller calibers for anti-tank guns. Distribution prioritizes the Eastern Front, where Soviet armor poses the most immediate threat. Western Front units receive progressively smaller allocations. By January 1945, many German tank units report having only a handful of tungsten core rounds per vehicle. British monthly output of 17-pounder ammunition, by contrast, reaches thousands of tons by this period. Factories in Britain and Canada operate continuously. Shifts run around the clock. Tungsten imports from overseas sources supplement domestic supplies. North American mines increase output. Recycling programs recover tungsten from expended ammunition and damaged equipment. The recovered metal returns to foundries for reprocessing. Industrial capacity expands rather than contracts. The contrast is stark. The industrial imbalance becomes a battlefield equation. The side that can fire more specialized ammunition more often holds a decisive advantage. German commanders recognize this. A memo from January 1945, recovered post-war, states, "No capacity for Panzer-40, 88 mm. Existing stocks exhausted the 88 mm tungsten rounds, used in Tiger tanks and other platforms, are unavailable. German guns must rely on standard armor-piercing shells with reduced penetration capability. Against Allied armor at typical engagement ranges, this reduction matters less. Against hardened targets or at extreme range, it becomes critical. British issue rates for armor-piercing discarding sabot ammunition increase through the winter of 1944 into early 1945. Frontline units receive regular resupply. The Firefly's effectiveness depends not only on gun design but on sustained ammunition availability. Logistics determine what is possible. The British logistics system, supported by North American production, delivers ammunition consistently. German logistics, disrupted by bombing and fuel shortages, cannot. Trains that should carry ammunition sit idle for lack of fuel. Trucks intended for supply convoys are diverted to tactical movements. Depots that should hold reserves stand partially empty. The Directorate of Tank Design begins planning post-war gun systems, but the 17-pounder remains the primary weapon through the war's final months. Operational research evaluations confirm its effectiveness. Reports compiled from unit actions across multiple theaters show consistent results. The 17-pounder penetrates German armor reliably at combat ranges. Crew training, ammunition quality, and tactical employment all contribute, but the weapon's fundamental characteristics, high velocity, flat trajectory, and powerful projectile, provide the foundation. The weapon shapes when and where German armor can move. In many instances, it determines whether movement occurs at all. German armored formations in the West avoid daylight movement in open terrain. They maneuver at night, under cover, or through wooded areas that restrict sight lines. These constraints limit operational effectiveness. Armor's primary advantage, mobility, becomes secondary to survival. The 17-pounder has forced this change. Factories, not formations alone, decide the result. The 17-pounder's edge, born from mathematics and engineering in 1941, becomes a systemic advantage by 1945. Columns of Sherman Fireflies cross bridging sites at Wesel on the 23rd of March, 1945. Sappers mark cleared lanes through debris. Smoke screens drift across the Rhine. Engineers work continuously to maintain the pontoon bridges and Bailey bridges spanning the river. Traffic control points regulate the flow. Tanks cross in organized groups, maintaining intervals to prevent overloading the bridges. The Firefly, conceived as an emergency adaptation in 1943, now serves as routine equipment in armored brigades. What began as a stopgap has become standard. Field returns from late March list over 2,000 Firefly vehicles in service across 21st Army Group. This represents a significant increase from the 200 available at D-Day. Production continued throughout the campaign. Losses were replaced. New units received Fireflies during formation. By the Rhine crossing, every armored regiment includes Fireflies in its establishment. The ratio varies by unit, but most achieve one Firefly per troop of 4 tanks. This provides balanced capability, 3 75mm Shermans for infantry support and 1 17-pounder for armor engagement. Armor-piercing discarding sabot ammunition reaches frontline units in quantities sufficient for routine issue. Supply dumps east of the Rhine stock thousands of rounds. Firefly crews no longer ration specialized ammunition. They fire when targets appear. This abundance reflects successful logistics. Factories produced the ammunition. Ships transported it. Trucks delivered it. Depots stored it. The chain functioned as designed. Crews benefit from industrial output measured in tons rather than dozens of rounds. British and Canadian armored divisions coordinate Rhine crossings with artillery and anti-tank assets. 17-pounder belts, both towed and self-propelled, provide overwatch. Forward observers call targets to gun positions. Artillery suppresses known German strongpoints. The anti-tank guns wait for armor. The combination provides layered firepower. German counterattacks must penetrate artillery fire, then encounter anti-tank guns, then face Fireflies moving with the advance. The defensive depth makes successful counterattack extremely difficult. The gun gives crossing forces confidence to face German counterattacks without yielding standoff advantage. Commanders know that any German armor appearing will face immediate 17-pounder fire. This knowledge influences decision-making. Bridgeheads can be held with smaller forces because the anti-tank capability compensates for numerical limitations. Operational research assessments from spring 1945 record first-shot success rates against Panther side armor at 1,000 yards markedly higher with 17-pounders than 75mm guns. The data supports what crews observe. The weapon works consistently under field conditions. German resistance east of the Rhine varies by location. Some units fight stubbornly. Others surrender readily. Armor encounters become less frequent as German fuel stocks deplete and replacement vehicles become scarce. When German tanks do appear, they often operate in small groups or individually rather than in formed units. The 17-pounder engages these targets at range. The pattern from Normandy repeats. German armor spotted at 1,000 yards, engaged, hit, neutralized. The tactical problem has become routine. Crews execute the drill without drama. Spot, range, fire, assess, move if necessary. The 17-pounder sets a post-war benchmark. Its ballistic performance influences the design of subsequent British tank guns. The 20-pounder, 84mm, and eventually the Royal Ordnance L7, 105mm, trace lineage to lessons learned from the 17-pounder's development and deployment. What started as an improvised installation becomes doctrine, high-velocity guns, efficient discarding sabot projectiles, and long-range gunnery training as core elements of Western armored practice. These principles guide post-war tank design across NATO armies. Test plates stand on frames at Chertsey and Schuberines in 1946. Post-war firings measure residual barrel life and penetration curves of 17-pounder guns returned from field service. Some barrels show erosion from sustained firing. Others retain acceptable accuracy despite thousands of rounds fired. The School of Tank Technology evaluates the weapon's overall performance across all variants: towed, self-propelled, and tank-mounted. Data from end-of-war trials feeds into next-generation gun development and discarding sabot ammunition design. Manufacturing techniques standardized during 17-pounder production inform post-war ordnance practices. Some analysts predicted the weapon would be immediately eclipsed by larger calibers. Instead, the 17-pounder's ballistic lineage shapes NATO anti-tank standards for decades. The Field Vehicle Research and Development Establishment studies the gun's recoil characteristics, mounting solutions, and ammunition performance in exhaustive detail. Lessons learned transfer directly to the 20-pounder gun and later the L7. A School of Tank Technology note from 1946 concludes, the 17-pounder constituted the most effective Allied anti-tank measure of the recent war. The weapon's development history illustrates a principle: wartime improvisation, when grounded in sound engineering and supported by industrial capacity, becomes lasting doctrine. The 17-pounder forced British and Canadian designers to solve problems: breech rotation, turret balance, ammunition stowage, that later generations of tank guns inherit as standard features. These solutions, born from necessity in 1943, prove superior to conventional approaches and influence armored vehicle design well into the Cold War era. Steel, mathematics, and organized production, not folklore, determined the armored war's result. The 17-pounder stands as evidence of that principle. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.